In this problem, in part A, they give you the acceleration, which I'm going to call acceleration number 1. And they give you the time for this acceleration, which I'm going to call t number 1. And it says that the sprinter accelerates at this acceleration for this time until he gets up to the maximum speed. So let's call that speed v. We know that v, since v is equal to v naught plus at in general, and in this case it starts from rest, so that's v naught is equal to 0. So that means that our v is going to be a1 t1 for the whole problem. Now a1 and t1 are both numbers that you know, so this is something that you can calculate. So this number, and this number are numbers that are known to you. So the first question is asking us to find the time for the whole race. Well, if we know that the first part is t1 and we know what that number is, what we really need to find is t2. So to find t2, we're in constant velocity, which is x equals x naught plus vt. V is this v over here, okay? Now, let's call this x number 2 and call the x naught for that time period 0. So x number 2 is going to be equal to v times t number 2, the second half, right? So x t2 here. Now, we know that the first part of it, x number 1, is going to obey the equation x naught plus v naught t plus 1/2 at squared. And x naught can be 0. V naught is 0 because it starts from rest. The acceleration is a number 1, and the time is t number 1. So x number 1 is 1/2 a1 t1 squared. This is a number that you can calculate because you know a1, t1, and, well, we know a1 and t1. So you can calculate x1. We know that x1 plus x2 is 100. So since you can calculate x1, you can now calculate what x2 is and then use that in this equation to find t2. But if you want to do it with the algebra, you can. You can say x1 plus x2 equals 100. So that means x1, which is 1/2 a1 t1 squared, plus x2, which is vt2, has to be equal to 100. So that means that t2 can be calculated as 100 minus 1/2 a1 t1 squared divided by v. And remember, we calculated v from just a1 times t1. Now remember that the answer to A is t1 plus t2. Okay? Now on to B. For part B, the tricky part is that we're going to have a new acceleration a2. We're going to have a new time for the first part, which I'm going to call t3, and a new distance, which I'm going to call x3. But the final velocity is the same. So in the acceleration phase, we're going to have these three, but the final velocity is going to be v, which is, as always, a1 t1, and you know these numbers. So this is a number you know. Okay, so this velocity, because v equals v naught plus at in general, and in the accelerations phase we start from v naught equals 0, this v is going to be equal to a number 2 times t number 3. Okay, now x number 3, just like the way x1 was 1/2 a1 t1 squared, x3 is going to be 1/2 a2 t3 squared, right? Now, from this, we know that T3 is V over A2, I can plug this in there and find out that X3 is also equal to 1/2 A2 V over A2 squared, which is V over 2A2, like that. So that's going to be X3. Now, let's make some room over here. To find X4, X4 is the distance traveled in the constant velocity phase, right? So in constant velocity, we have X4 that we don't know what it is. We have the velocity v, that's a1 t1, the one we always knew, and we have a time which I'm calling t4, right? Well, we know that X4 is equal to v times t4 because it's constant velocity. That's the equation. And we also know that t3, the time for this phase, plus t4 has to be equal to the total time that they want it to be, which I'm going to call b. B is the total faster time for this race. This is a number that you know. It's in your problem. All right? So what we know is this. So that means that T4 has to be equal to B minus T3. But T3, you remember, is V over A2. So T4 is B minus V over A2. All right? So now, that means that X4 is equal to V, like here, times B minus V over A2. Whew. So now we have X3, which is over here. Let me get the color. Here's X3, and here's X4. And we know that X3 plus X4 is equal to 100. So that means that V squared over 2A2 plus V times B minus V over A2, like that, has to be equal to 100. And when you work with this, you need to multiply both sides by 2A2 to get rid of the denominators. So let's see. We're going to multiply this thing by 2A2 and this by 2A2. And so that's going to give us V squared plus 2VA2B minus 2V squared equals 200 A2. And you can solve this for A2. A2 then is going to be equal to V squared over 2VB minus 200. And remember, B, what's another color I can use? B is here, and V is there. You can calculate it from the numbers you had.